I'm going to just quickly run through the idea of Pythagoras' theorem. So Pythagoras' theorem is a really, really important theorem in maths and particularly, I suppose, in trigonometry and different areas of maths as well. But it's to do with triangles, and I suppose specifically it's to do with right-angled triangles. So right-angled triangle is like the one you see here on the left, where we have a nice little right angle in one corner, and when we have a triangle like this, the sides of the triangle follow a particular rule, and this is the theorem that we have. And the rule is written there beside the triangle here. So the rule says that side C squared is equal to side A squared plus side B squared. So looking at the way that we have them here, B is here. Sorry, putting them in the wrong colours. So B is here, A is here, and then side C is over here. So comparing and setting it up with the way that it is here, side C is the side that is across from the right angle, and it actually has a particular name. So side C is actually called the hypotenuse of the triangle. Side C. So a right angle triangle, the longest side of a right angle triangle is called the hypotenuse, and it's the side that's opposite to the right angle. Okay, so a general rule, I suppose, is that the biggest angle or the biggest side in a triangle will be opposite to the biggest angle. But there's, I suppose, a particular case of that as well. So the hypotenuse is the longest side in a right angle triangle, and it's directly opposite to the right angle. So you can see there with the theorem, it's important that when you're using the theorem and labeling your sides, that you do label them correctly, because there is only one side that's out on its own here, and it's always the hypotenuse. Okay, it's always the hypotenuse. So really this theorem says that the hypotenuse squared is equal to the sum of the other two sides squared. And that's really, really important. So I suppose the biggest thing you could do wrong in a question with Pythagoras is to label the sides incorrectly. So it's really important that that's the first thing you do. The way that I've put the theorem in here is the way it appears in your log table book, in the formula and tables book. So that's important that that's the way you're getting familiar with it, that's what you're getting used to seeing, and that you're able to kind of make use of the formula in that form. So let's just go through a question or two on that really. So jumping straight in, find the length of x. So we're using Pythagoras' theorem, so we know already from our work that c squared is equal to a squared plus b squared. Okay, so labeling my sides here, from what we've said before, the one opposite the right angle is the longest side, and that's c, so that's going to be the 29. A and b, it actually are interchangeable there. It actually doesn't matter. So a and b are interchangeable. So once we've labelled our sides, it's a matter of just substituting them into the formula there. So we're saying c squared, which is 29. So 29 squared is equal to 20 squared plus x squared. So you can see here, I'm not saying, well, I don't know what x is, so that's going to have to be the one that's on its own. No, I am first labelling my sides as I would normally do, and I'm subbing them into the correct places, and then I'm seeing what I'm going to find for x, and I'm going to try and solve for x here. So 29 squared gives me 841, 20 squared gives me 400, and x squared, of course, is just x squared. Now I want to get rid of the 400, I want to get just x on its own, so I'm going to take away 400 there from both sides. So I get 441 is equal to x squared. Now I don't want x squared, I want to get that value for x on its own, and in order to do that we have to make use of what we call the square root. And in the same way that like multiplication and division are opposite operations and addition and subtraction, squaring and square roots are opposite operations. So if I have squared, then to square root it will give me the opposite, will take me back to the original result. So that means that x is 21. So if x squared is 441, that means that I started with 21. X was 21. Okay, and that's really the gist of it there. It's just a matter of applying that theorem. Let's look at the next one here. Find the perimeter of this right angle triangle. So same idea again. I know my theorem is c squared is equal to a squared plus b squared. Let's label my sides. The side c is always across from the right angle, so that's going to be x this time. A squared and b squared are interchangeable so long as it's not the hypotenuse. So let's substitute in. So c squared, so x squared equals 24 squared plus 7 squared. So I get x squared equals, what's 24 squared? Well, I don't know, so let me go to my calculator. 576. 7 squared, I should know as well, is 49. I'm going to be adding those together this time. So you can see here now the sum is turning out slightly differently because of what the unknown side is. I have a little less movement to do here. Same as the last time, if x squared is 625, then that means x is the square root of 625, which is 25. So x is 25, and in this question it was find the perimeter. So the perimeter is 24 plus 25 plus 7, which is going to be 56 meters. 56 meters. Okay. Let's look at one last example. Here, a rectangle is 10 centimeters in length and 8 centimeters in width. So 10 centimeters here, 8 centimeters here. Calculate the length of the diagonal. Well, the diagonal is going to be this line here. And we can see that by doing that line, we should know that a rectangle has a right angle here. So what I've done is I've created a right angle triangle, which has 8 here and 10 here and an unknown value here. Now, from my Pythagoras theorem, I know c squared is equal to a squared plus b squared, and I know that c is the one opposite the right angle, so it's going to be x. So x squared equals 10 squared plus 8 squared. X squared equals 100 plus 64. So x squared equals 164, which means x is the square root of that. And that's going to give me, okay, 12.80625. And I was asked to give my answer to one decimal place, so that's 12.8 centimeters. Okay, so with Pythagoras there, the theorem itself is fairly simple. It's fairly short, as theorems go. It's fairly kind of just, here it is. But the main thing here is what we've done in this first little step here is making sure that you can label your sides correctly. So labeling the hypotenuse, labeling the other sides, then noting that A and B are interchangeable so long as C is the correct one, is the one opposite the right angle, the longest side opposite the right angle. That's always your hypotenuse. Once you've that done, if you lay that out before each question, and I would say if you're doing a question of Pythagoras, always write down the theorem, then substitute in your sides, having labelled your triangle. And if you do that, then you should be able to keep it consistently working well. Noting just for, say, like questions like this first one, where you maybe have to do some rearranging before you can find the value of x, whereas alternatively then in the next two, x was the hypotenuse, which can sometimes be a little bit easier then to solve for. But as I say, just making sure you're comfortable with that theorem, that you can label your triangle correctly, and that you can then follow through in solving for that unknown side.